Clear po.
Clear naman. Okay. So, hello everyone again, and welcome to another class lab of APLTRIG. So today we'll discuss yung answer sa previous quiz nyo, yung Blade Fury. Then, we'll be also discussing the right triangle and about yung sine cosine, SOHCAHTOA, the hypotenuse of the parts of the triangle, and ayun. So, okay. If you guys remember the quiz, it's about Blade Fury and yung si Juggernaut, tapos umiikot-ikot siya. And what we have here is he spins for 3.25 times every second. A full rotation of 3.25 times every second. He deals 155 damage per full rotation. Blade Fury lasts for 5 seconds and it goes into 18-second cooldown. Now, oh, not that one. First question is, if he was facing at 67 degrees, after Blade Fury, in which direction will he be facing? So if we try to solve it, again, nag-start siya at 67. Oops. 67 degrees. Yan yung starting niya. Then, we compute how many times did he rotate. So, we have 3.25 times every second. And his skill lasts for 5 seconds. And he does a full rotation, meaning he does 360 degrees. So 3.25 times 5 times 360, get our calculator, 3.25 times 5 times 360. Get 5,850. So 5,850 plus we have to add yung offset niya, which is si 67 degrees. So plus 67, we get 5,917. 5,917. And we bring it to only 0 to 360. Answer is 157. So after using his skill, he is now facing 157 degrees. Hopefully, I think mostly everyone got that naman. Now, ito, second question. How much total damage will Blade Fury deal on 3 enemies in its full duration? How do you solve that? So, given ulit, di ba? Na 3.25 times per second the full rotations, and he does it for 5 seconds. Kasi yun yung skill duration niya. And the thing is, his damage only registers kapag full rotation. So all we need is the floor. Bakit floor? Because when you compute this, this is 16.25. Ang sabi dito, he deals 155 damage per full rotation. So itong 0.25 na to does not deal any damage kasi hindi siya full rotation. So if we floor it, we only get the total amount of spins of full rotations he did, which is 16, right? So he rotates, he does 16 full rotations. So multiply that to amount of damage. And we multiply that to the amount of enemies, which is 3. 3. So 16 times 155 times 3. You get 7,440. Does everyone get this naman? Kuha naman. Because again, 155 damage per full rotation. So we just get the floor of yung how many rotations he did during his skill, and then multiply the damage and the amount of enemies. Okay? Next. And this is the part where I've been giving you guys hints. So he hits an enemy after 1.33 seconds upon activation. So si Blade Fury hits the enemy for the remainder of the duration. How much damage will Juggernaut deal? So to solve this, we actually get the amount of spins the enemy did not uh, get. Right? How many spins did he not get? So 1.33 seconds. So if we do um, floor again of 1.33 seconds times 3.25. Bakit? So in this 1.33 seconds of him not with not being damaged, he has spun if you multiply the 3.25, we get the amount of times he spun around without dealing any damage. So 1.33 times 3.25, 4.32, but floor, so we have 4. So si Juggernaut spawned 4 times without dealing any damage. And we just subtract that to the amount of times he usually deals damage uh, during the duration. So we have 16 minus 4 and multiply the amount of damage per full rotation. So 16 minus 4. Oops, sorry. 16 minus 4 multiply by the amount of damage per full rotation. 1,860. Okay? Kaya sabi ko, use yung amount of times he did not deal damage. So you could subtract it on the amount of times he would usually deal damage. Alright, ko naman. I think mostly everyone got this. No questions so far? Okay, so no questions. Now, similar case to the previous question, but another enemy approached you 1.4 seconds after the first enemy got hit. How much total damage did Juggernaut deal? So almost the same thing, but this time he arrived 1.4 seconds after the first enemy. So how long did he how many seconds was Juggernaut spinning without dealing any damage to this second enemy? So if we taking into account the seconds of the first enemy, 1.33, we add the 1.4. This is the total seconds of him not dealing any damage. And again, we multiply it by 3.25 and we floor this. 1.33 plus 1.4 times 3.25, we get 8.8725, but we use floor, so we get only 8. He spun 8 times without dealing any damage to the second enemy. So how much damage did he deal to the second enemy? We minus that by 16. So 16 minus 8. This is the amount of times he dealt damage. We multiply the 8 to 3.25. And we floor this. Sorry. We floor this. Wait lang. Tama ba ako? Ay, joke lang. Sorry. 8 times 155. This is the amount of damage he dealt in this amount of spins. We have 8 times 155. It's 1,240. He dealt 1,240 on the second enemy. But the question is, how much total damage did he deal? So 1,240 plus our 1,860, you get 3,010. Okay? So that is total damage he dealt to both of the enemies. Kuha naman. No questions on this? Okay. No questions. Finally, ito. So si Juggernaut, he was facing north. Every time he finishes Blade Fury, he moves or he rotates 90 degrees relative to the direction he's facing after Blade Fury finishes. He only does this when the skill is on cooldown. So in which direction in degrees will Juggernaut face to after 200 seconds? So this is our simulation. And balik tayo. We can clear this up. Okay. So he was facing north. We have that 90 degrees. Then for 200 seconds, ano mangyari? So what we want is how many times did yung skill and yung cooldown happened? How many times did this skill and cooldown happen? So we have 5 plus 18. We end up with, so every 23 seconds, he would spin and then do a 90 degree, right? So 200 seconds divided by 23, we get the amount of times he will do the spin and the cooldown. So 200 divided by 23, we have 8.69. 8.69. That's how many times he did the skill and naka-cooldown siya. But what we want is only the 8. Yung 0.69, that is the excess amount of seconds na, excess amount of seconds nga na he did after ng skill and yung cooldown. So if you floor this, if you get the floor of 8.69, we get 8. So he did the skills and naka-cooldown siya 8 times. So ano yung excess seconds natin? So 200 minus 23 times 8, we get, so 23 times 8 minus 200, we get 16. So for ito yung excess seconds natin. Okay? And this excess seconds, ano nangyari? He was able to do his Blade Fury kasi 5 seconds lang siya. Usually, ang math nito, I mean, if you were to program this, it would have been like, Well, kasi naka full skill naman siya. But if this was like less than a full skill, how we would have done this in programming would have been like minimum of yung 5 seconds and then yung excess seconds, and then multiply this to how many times does he rotate? 3.25 times 5 times 360. He rotated 5,850 divided by the amount of times he rotates. The amount of seconds he rotates. If this was in programming. Kasi kung hindi siya 16, what if it was like 4 point something, right? Then we would have to get the angle after yung angle ng seconds after the seconds na yun. So if you just do this, it would have still been 5,850. So again, itong 16 na to, this is the excess, right? If this was below 5, that means the simulation ended while he was spinning. So we get the amount of rotations he was able to do before the simulation ended. That's why we have this. But, you don't really have to do this if you can read the excess seconds, right? Next, ang question is, nag-cooldown pa siya, di ba? So, another way to program this would have been like the floor of ay floor pa to. Uh, Tama. The floor of the minimum of 5 and 16, and we multiply this by hold on, tama ba ako? 516 no, divided by 5. So what does this mean? If the simulation was less than, the excess seconds was less than 5, this would have been like, ano, tama ba to? Yeah. So if the simulation was less than 5, let's say 4 or 3, 4 divided by 5 would have been like 0.8. And for that, it would have been 0. So anything above 5, like 16 or something, minimum will be 5. 5 divided by 5 is 1. Floor is equal to 1. And we multiply this by 90. This just to show kung nag-rotate ba siya ulit kasi kung naka-cooldown siya. So if this is less, if this was than 5, hindi siya nakapag-cooldown, hindi siya nakapag-rotate ng additional 90. So we have 90. So let's bring this all up together. You have 90. Nag-start siya ng 90 degrees. He was able to do his skill and nag-cool down 8 times. So 8 times 5,000. How many times does he rotate? 5,850. Right? Plus, ilang times siya nag-cool down? 8 times 90 kasi he rotates after he cooldowns. Plus, yung excess na seconds natin, he did 5,850. And he also did the excess excess seconds for the cooldown, 90. So, we have 90 plus 8 times 5,850 plus 8 times 90 plus 5,850 plus 90. You get 5,300, 53,550. 550. And mu modulo 360. You get 270 degrees. That's where you'll be facing at after all that, after the 200-second simulation. I know medyo itong part na to, is just like some programming stuff. Pero without programming naman, you would have noticed that itong 16 seconds he was able to do his skill and the cooldown. So we just add that 5,850 and then the 90. Okay. Gets ba? So again, anong ginawa natin? 200 seconds. How many times was he able to do his skill and his cooldown? So nakuha natin was 8. And then we have that extra seconds of 16, meaning in this 16 seconds, anong ginawa niya? Nag-skill siya and nakapag-cooldown siya. So we have that 5,850 because it is one whole skill, and then the 90 kasi nag-cooldown siya. Add them all up together, you get 270 degrees. Any questions? Madugo? No questions? So, I'm guessing nakuha nyo lahat naman yun. Actually, maming hindi nakuha. Pero, I gave them an additional 5 seconds ulit. 5 points kapag may sagot kayo nun. As in, any answer you give, I would have given them 5 points. Alright? So, again, kung no questions, no questions? Okay, so kung walang questions, we can proceed with our discussion for today, which will be on right triangles. Alright. So, right triangles. I'm pretty sure naman yung instructor nyo sa applied trigonometry was able to teach itong mga right triangles na to. But anyway, we'll get to it again. So, ano yung parts of the right triangle? Ang right triangle, meron siyang hypotenuse, may opposite, and adjacent. So hypotenuse will always be the longest side of the triangle, no matter what. Ito yung pinaka habang side in a right triangle. Then we have the other two sides, opposite and adjacent. Now it will depend on the angle of reference. So si alpha, again ito, yung opposite niya will be here, meaning the opposite side, whatever is it's looking at, right? Adjacent will be that other line that is not the hypotenuse. It'll be the one right beside the angle. Same thing with beta. See beta, this would have been the opposite. Again, it's facing the opposite side of the angle. Then we have the adjacent right here. Okay? So, sa angle A, again, ito yung opposite, si BC. And then we have the adjacent, CA or AC. And kapag sa angle B, ang opposite natin would have been CA, adjacent would have been BC. Alright? So C adjacent, again, basta hindi siya yung hypotenuse ah. Hypotenuse will always be the hypotenuse. It's used for something else. So always, adjacent would have been the side na hindi opposite and hindi yung hypotenuse. Ito lang naman. So if you practice, okay. Relative to angle G, which side is the adjacent side? Anyone? Ano yung adjacent side natin? On angle G. MG. Tama. Yung line MG nito is our adjacent side. Because it's not the hypotenuse. Ayan. MG. Angle N. So relative to angle N, which side is the opposite side? Anyone besides Astilia? ED. Tama. Ito yung opposite. Okay? Dali, no? What is the hypotenuse in the triangle sky? Oh, anyone besides ano? KYYK. Tama. So, line KY or line YK. Same answer. Okay? Okay. Gets nyo naman. Now, we have here si Sokotowa, which is our really easy way to remember trigonometry ratios. So, si Sokotowa, we have sine of opposite over hypotenuse. Sa ka, we have the cosine of the adjacent over the hypotenuse. And then toa would have been the tangent of opposite over the adjacent. Okay? Yeah, so ka toa. Sine opposite. The sine of the angle is all equal to the opposite over hypotenuse. The cosine of an angle will be the adjacent over hypotenuse. And then tangent will have been the the tangent of an angle will be opposite over adjacent. Given na to, given in a right triangle, this will always be correct. So when is it useful? So if you know one angle and one side, and you need to know the other sides, you will be able to use Sokotowa. You'll get those. If you know the two sides, and you need to know the angle, makakuha mo agad yung angle na yun. If you can fill the variables of a formula so that it only leaves one missing value, then it's good. So what if we don't have any angle and we only have two sides? Sige. We'll go through here muna. So yung Pythagorean theorem, if you call it during your, either in APLTRIG or back in high school, it's a squared plus b squared is equal to c squared. And proof talaga yun. So given a right triangle, a squared plus b squared will always be c squared. So finding the missing side if the two sides are already given. So in game dev, this is commonly used to find the distance between 2 points. Okay. So paano natin i-check yun? Let's say we have a right triangle. We have this. We have a right triangle. Which would have been like, let's say ang given natin is itong 3 and 4. We're able to get this hypotenuse using the Pythagorean theorem, which is the a squared, again, diba? A squared. Ooh. A squared plus b squared is equal to c squared. So c will always be the hypotenuse. So we have 3 squared plus 4 squared is equal to c squared. But if we square root both sides, we have 9 plus 16. The square root of 9 plus 16 is equal to c. And we have 25 The square root of 25 is 5. Right? Makakuha mo agad yun using the Pythagorean theorem. You'll be able to get that this is 5. Kahit na if not yung ano, itong 4 na to, kung wala yung 4, you can still use it. You have 3 squared plus, I don't know, b squared is equal to 5 squared. Given. Always given na the hypotenuse is yung c. We end up with 9 plus b squared is equal to 25. We move 9 to the other side and square root both sides. We can end up with b is equal to the square root of 25 minus 9. B is equal to 16. So the square root of 16 is 4. Okay? Now when it comes to angles, I think that's the next one of this. Ayan. If you want to get angles naman, we use the inverse trigonometric ratios. So this is useful if you're looking for a specific angle, given that you already know at least 2 sides. If you, okay, sige, let's continue. Trigonometric functions, input angles. Okay? So, see inverse trigonometric ratios, basically, if you do, hold on. Okay. Diba we have sine 30? See, sine 30 will always give like, hold on, trigonometry. Okay. See, sine 30 would always give like a, no, that's cosine. 0.5, right? That is sine 30. Oops. Sine angle. Okay. Pero, if you actually get the arc sine or a sine, ito, this means arc sine. If you get arc sine of 0.5, arc sine, makakuha mo dito. Is there arc sine here? Arc sine. Oh my. Is it 8 lang? Oh, wait lang. Wala ba dito? Arc sine. Arc sine of 0.5. In degrees. It's 30 degrees. So basically, it is the inverse of yung inverse ng function na to. So instead of given sine angle, if we do the arc sine of the ratio, we get the angle. So if you want to get this angle, oh my, if this angle, which one do you use? Sine, arc sine, arc cosine, or arc tangent? Given that we have 3 and 5. What do you guys think? Arc sine, arc cosine, arc tan. Because remember, SOHCAHTOA, si SOHCAHTOA is SOHCAHTOA. Remember that's SOHCAHTOA will be sine. We have opposite and hypotenuse. Kapag cosine, we have adjacent and hypotenuse. And we have kapag tan, we have opposite and adjacent. So ano meron natin? What do we use here? So tama si Greco, sine. So if we use arc sine of 3, over 5, we should be able to get the angle. So 3 over 5. We would have like 36.86 degrees. 36.86 degrees. Okay? Paano kung ang meron lang natin is itong 4 na to? Then what do we use? Anyone? Na hindi si Yatko? TOA. So we use TOA, which is tan. So we had the tan, arctan of opposite over adjacent. We should still get the same answer. Arctan of 3 divided by 4. We still get 36.86 degrees. Okay? So that's how the inverse works. The inverse trigonometric ratio. So if you want an angle, we use the arcsine, arccosine, and arctan. And itong negative 1 na to, if you recall sa algebra nyo, usually it means like in power, right? Like itong 5 squared, right? So kapag 5 squared, we know that it is a power of 2 to the 2. So that is 5 times 5. Pero kapag naging negative yung power nyo, that just means 1 over 5. Or kapag 5 to the negative 2, that would be 1 over 5 squared, right? That's what our power usually does. Pero, itong negative 1, it does not work the same way with yung sine, cosine, tangent natin. Because it's a function. Sine is not a number, but a function. That's what this all just basically means. So instead, the negative 1 means it is the inverse of that function. So, yung sine natin, our sine angle would have given the opposite over hypotenuse, the ratio. But the inverse of sine, if we get the arcsine of the opposite over the hypotenuse, we will get the angle instead. So it does the complete opposite. Alright. Any questions so far? Nakuha nyo naman? Gets nyo naman? Was this taught? This was taught naman, no? During yung class nyo. Right, okay. That's good. So there's no questions. You fully understand. Understand yung Sokotowa sine. Okay. Good. Next, we have angle of elevation. So this just basically means the angle between the horizontal and your line of sight to the object. So if the object is above, ito yung angle of elevation natin given the horizontal. Angle of depression, opposite naman. If we have this horizontal and the object is like below that horizontal, this is the angle of depression. So, given like itong line na to, This here is our angle of elevation. Elevation. But itong angle na to is our angle of depression. Depression. Because it is pointing downwards. Yun lang naman yung ano, yung kailangan nyo malaman. Kapag pababa siya, and this is your horizontal line, this is your angle of depression. Pero kapag pataas siya, this will be your angle of elevation. Okay, okay? So, itong ano, using Sokotowa, this right triangle, it's actually just like a basic requirement sa game dev. Why? It's actually very useful sa mga spatial problems. If I want to know the angle of where, um, the angle that I need, of like a projection or a projectile, makuha ko yun given the the values of where it is, the x and y axis, ayun. Same thing with distance. You're able to get that using our Pythagorean theorem. A squared plus b squared is equal to c squared, right? Given their x and y axis, x and y values, and the origin of the x and or whatever that other x and y values, I am able to get the um, distance. Okay? So very useful. Very useful ang Sokotowa and yung Pythagorean theorem. So as programmers, we are more concerned how to apply the actual math. We need to do math, not just understand it. So we don't have all the time to study everything. So just using this, medyo okay na to. Medyo. If you want to get more complicated, then you have to do more studying. But ito pa lang, you're able to create games just by having their distance formula, the angle. Ayun. Any questions? Or do you guys want an example how we use this for the um, distance formula? All good. So ito, just so you guys can see. Oops. That's an example of how we could use it. Let's say we have 2 points in our grid. We have this and we have this. We have x, y, this is x1, y1, this is x2, y2, this is their points. How do we get the distance? So to get this distance, we actually have a right triangle right here. Ito yung right triangle natin. All we have to compute is whatever this is. Oops. Whatever the length of this side and whatever the length of this side. And we should be able to get our hypotenuse. Later on, you can even get our angle of elevation, how to get it. Pero let's say our distance lang. So, ang distance natin would be like, to get A, we have the x values. So, you have x2 minus x1. This is the side. Itong side na to. Itong side naman to would have been y2 minus y1. So we have A and B. If we get the sum of their squares, we would get itong part na to. And to simplify it, if we square it both sides, they could just get C. We get our distance formula of x2 minus x1 squared plus y2 minus y1 squared. And we will get C. Okay, so that's how we use our Pythagorean theorem in getting the distance. We could even get an angle, and pero di naman kailangan. Okay? So, ayun. That's our use for right triangles. Any questions? No questions naman? Kasi kung walang questions, we have a exercise naman for you to do. Exercise will be 3-1. So right here we have our trigonometric or triangle 3, 4, 5, and then we have our alpha. So ang bibigyan nyo is ano yung sine alpha, ano yung cosine alpha, ano yung tangent alpha given itong triangle. Okay? Then we have our inverse trigonometric ratio. Hanapin nyo kung ano yung angle A using only 6 and 8. So try to recall yung SOHCAHTOA. Then for angle of elevation, itong part na to, you use your you use SOHCAHTOA again here. Given we have our hypotenuse and our angle, you should be able to get the kung ano dito, how far from the skydiving center did Alexa land? So, gaano kalayo? Given itong mga values lang natin. Okay? So, you guys work on it for 15, 20? Is 15 minutes okay? Is that long enough? Or you want 20 minutes? Okay, we're going with 20 minutes. Okay? So, gawin niyo yung exercise, then we can discuss after. Alright?